All right, let's talk about something super practical. You've got a powerhouse model like Google's Gemma 4 running locally, which is awesome. But how do you actually take that and make it ready for the real world, for production level scale? That's exactly what we're digging into today, a guide to using vLLM to do just that. Okay, so here's what we've got on tap. We'll start with the huge problem you run into when you try to scale a local LLM. Then we'll look at how vLLM is basically the engine built to solve it. After that, we'll walk through a step-by-step on serving Gemma 4, talk about scaling up for tons of users, and finally wrap up by seeing where vLLM fits into the whole ecosystem. Let's get to it. Right. Let's start with the core issue. You've got this incredible open source model running on your own machine. It's fast, it's powerful, it's perfect for you. But what happens when you need to serve a real application? When it's not just one person, but 100? So your first thought might be, I'll just throw a faster GPU at it, right? Well, it's not that simple. The real challenge isn't just about raw compute power. It's all about memory management. See, the way traditional inference engines work is totally fine for a single user. But the moment you try to handle hundreds of simultaneous requests, they just hit a wall, a massive bottleneck. Okay, so let's get into the nitty-gritty of why this happens. It's all about something called the KV cache. To generate text quickly, the model needs to remember what it's already said. It's like it's short-term memory. But here's the crazy part. Look at this. Old-school systems waste, get this, 60 to 80% of the GPU memory they set aside for this cache. It's because of a problem called fragmentation, leaving all these small, unusable gaps in memory. And the result? All that expensive GPU power is just sitting there, doing nothing. And this exact memory problem, well, that's what vLLM was built for. It was designed from the ground up to solve this specific issue, which is why it's become the go-to for production-level, high-throughput serving. And the difference is, well, it's not small. We're talking up to 24 times higher throughput than what you get from a standard Hugging Face implementation. That is a massive jump. So the big question is, how on earth does it do it? The first piece of magic is called paged attention. And honestly, it's a brilliant idea they borrowed from old-school operating systems. Instead of trying to find one huge, continuous block of memory for each request, it breaks the memory into these smaller pages. And that one change almost completely gets rid of that wasted space. We go from that awful 20 to 40% GPU utilization all the way up to over 96%. It's a total game changer. Okay, so that's the first key. The second is something called continuous batching. Imagine a theme park ride where the operator waits for the entire car to empty before letting anyone else on. That's the old way, slow. Continuous batching is like a smart operator who lets new people on the moment a seat opens up. It just injects new requests into the GPU's queue the second there's a free slot. The GPU is always working, you get your answer back way faster, and the whole system can handle a ton of traffic without breaking a sweat. Okay, that's the theory, and it's super cool, but talk is cheap, right? Let's get practical. How do we actually use all this power to serve a real model, like Gemma 4? You're probably thinking it's going to be complicated, but you'll see it's shockingly straightforward. Seriously, it boils down to just 3 steps. First, you install it, pip install vLLM, or just grab the Docker container. Second, you fire up the server and just point it to the Gemma 4 model on Hugging Face. One command, and boom, that's it. You're ready to connect your apps. And here's the best part. It spins up an OpenAI-compatible API. That means you can swap out a cloud service for your own local, super fast model with almost no code changes. That's huge. And it gets even better because vLLM isn't just for text. When you're working with a beast of a multimodal model, like Gemma 4, it really shines. Let's say you want to feed it a video. You don't have to worry about all the complicated pre-processing. You just send the video file to the API, and vLLM takes care of the rest. It'll break it down into the text and image frames the model needs, all behind the scenes. It just works. So getting one server running is awesome. But real production isn't about one server. It's about handling huge workloads, right? This is where we go from a single GPU to a whole cluster, and where vLLM's parallelism features really come into play. And what's so great about vLLM is that it gives you a super clear path to scale up. You can start with one GPU, which is already incredibly efficient, but when you're ready, you can scale out to a multi-GPU setup to handle either enormous models that won't fit on one card or just insane amounts of traffic, all without having to go back and rewrite your main application logic. This is the really crucial part. vLLM gives you the exact tool you need for whatever scaling problem you have. Is your model just gigantic? Too big for a single GPU? No problem. You use tensor parallelism to literally split the model's brain across multiple GPUs. Or maybe your model fits fine, but you're getting slammed with a ton of users all at once. Easy. You use data parallelism to make copies of your model and balance the traffic between them. This flexibility is what makes it a true production-ready tool. Okay, so we've gone deep on how to get vLLM up and running for production. Now let's zoom out a little bit. It's super helpful to see where vLLM fits in the bigger landscape of all the tools we have for running local LLMs. This table pretty much breaks it all down. If you want maximum performance for just yourself on pretty much any device you own, you're going to use llama.cpp. If you're a developer and you just want a convenient, always-on model server for experimenting, that's a llama. But the moment you're building a real application that needs to serve a lot of people at once and be super efficient, that's when you bring in vLLM. It's the right tool for that job. And look, this isn't just some academic chart. This quote from Reddit nails it perfectly. People are using Llama CPP on their home machines and then deploying with vLLM at work. It's exactly how these tools are being used in the real world. So the big takeaway is simple. When your project grows up from a personal prototype into a real production application, you have to switch your backend to something like vLLM. It's essential for handling that scale, which, leaves us with a pretty interesting question. What happens when the hardware on our home devices gets so powerful that these lines start to blur?